Welcome to our exploration of forensic sciences where science meets justice. In this presentation, we'll unpack the tools, methods, and principles investigators use to connect evidence to truth, and we'll highlight how laboratories, fieldwork, and technology work together to solve crimes and support fair outcomes. Forensic science applies scientific principles and methods to legal questions, helping investigators interpret physical evidence. A key idea is Locard's exchange principle, which reminds us that every contact leaves a trace, so tiny fibers or fingerprints can link people and places. The slide's graphics show how evidence transfer is central to investigations. Forensic science evolved over centuries, from early documentation and observation to modern biological analysis. Milestones include ancient manuals, the recognition of fingerprint uniqueness, public interest sparked by Sherlock Holmes, the creation of institutional crime labs, and the DNA revolution that transformed identification and criminal investigations. DNA analysis has become the gold standard, moving samples through extraction, quantitation, PCR amplification, separation, and final analysis. Techniques like autosomal STR profiling, Y chromosome testing, and mitochondrial DNA give investigators powerful tools to identify individuals, resolve cold cases, and provide high-confidence evidence in court. Crime scene investigation follows a careful sequence to preserve and document evidence, secure the scene to prevent contamination, conduct a primary walkthrough to plan the work, photograph and sketch, collect and package items properly, perform quality checks, and maintain a strict chain of custody to protect integrity. Forensic pathology and toxicology work hand in hand to uncover causes of death and the role of substances. Pathologists perform autopsies, tissue analysis, and injury assessment, while toxicologists identify drugs, poisons, and alcohol using techniques like GCMS, together building a clear medical and chemical picture of events. Digital forensics focuses on recovering and analyzing electronic evidence through the DFIR steps: identification, preservation, analysis, and documentation. Investigators use tools like NCASE and FTK for log analysis, malware reverse engineering, and network traffic review to trace data breaches, fraud, and cyber attacks in modern investigations. Specialized forensic disciplines add depth to investigations. Anthropologists identify skeletal remains and build biological profiles. Odontologists use dental records and bite marks. Trace evidence experts analyze fibers, hair, glass, and paint. Ballistics compares firearms and bullets, and document examiners detect handwriting and forgery. Looking ahead, forensic science combines innovation with core principles. AI and machine learning are speeding up analysis, improved facial recognition, and automated pattern matching aid identification, and 3D imaging and rapid DNA promise faster results, all while scientific rigor and an emphasis on justice remain essential to prevent wrongful convictions.